Okay guys, today is lesson 1.6, solving absolute value equations. So this lesson takes a little longer, so if you're watching from home, we're spending 2 days on this, so if you want to watch the video in one day, that's okay, but we're going to spread this out over 3 days, 2 days just with the lesson. So anyways, solving absolute value equations. So starting with example 1, they give us A and B, and they tell us to graph the solution if possible. When we have absolute value in an equation, the first thing we have to do is we have to turn it into two related linear equations. So what that means, looking at problem A, they took this problem, the absolute value of x minus 4 equals 6, and turned it into both of these equations. So we have x minus 4 equals 6, they just took the absolute value away, or we have x minus 4 equals negative 6. So the reason they did that is because when we are taking the absolute value of something, you always get a positive answer, because absolute value means a number's distance away from 0. So if you're looking at a number line, you're just counting how far away it is. Distance is never negative. We can use negative numbers to represent like a direction, as far as like up, positive, down, negative, but distance itself is always positive. So when you take the absolute value of something, whether it's a positive or a negative number, you're always going to get a positive answer. So when we have an x involved, we could have a positive or a negative, we don't know, because the answer came out positive from absolute value. So we have to take this one problem and turn it into two possible equations so that we can solve for x. So looking at this, what you do on that second side, when you're taking the absolute value out, you only ever look at the second side of the equal sign. You would change and multiply everything over here by -1. Since it was just a 6, that was easy. It became -6. Now we go back and solve them. So here we have x minus 4 equals 6. So to solve that, we would add 4 to the other side of the equal sign, and 6 plus 4 is 10. So we get x equals 10 here. Then on this side, when we add 4 to the other side, -6 plus 4 is -2. So both of our solutions, or we have two solutions, it says they are x equals 10 and x equals -2. Because both of those, if we were to plug it back in here and then take absolute value, we would get +6. So then on this number line, they just showed us, okay, here's -2 that we got, here is 10 that we got, and since it said -4, if we were to start at 4, each of those answers we got is 6 units away. Because remember, absolute value finds a distance, and it found a distance of 6 on this one. So they are 6 units away from 4. Okay, we're not really going to focus too much on graphing on a number line. I just wanted to show you how it actually works. But we're mainly focused on finding these solutions. Okay, so then if we look at example B, it says the absolute value of 3x plus 1 equals -5. So if we look down here at this one, this equation, we don't even have to work it out. The answer is just no solution. And there's a symbol we can use in here for no solution. It's just like a 0 with a diagonal line through it. It means no solution. The reason, and I'll read their explanation and then I'll expand on it a bit. It says the absolute value of an expression must be greater than or equal to 0. So there's no way that it can equal -5, because when you take the absolute value of something, we just talked about this, it has to be a positive answer. There's absolutely no way you can get -5 when you take the absolute value of something. So for it to say that the absolute value of all this equals a negative number, there's just no way. It has no solution. Okay, so I want you to attempt problems 2 and 3 at the bottom. You don't have to do number 1. You can for extra practice, but do problems 2 and 3. Pause the video so you can work them out. And then when you press play, I will work them out on the board for you.
So I just want to reiterate that the whole reason we do 2 problems for each one and you turn it into 2 linear equations is because when we take the absolute value of something, your answer always comes out positive because it's a distance, and distance can't be negative. So for example, the absolute value of 2 we know is 2. The absolute value of -2 is still 2. So whenever you have an x in there, we know x could be 2 or -2 for this to be true. So we have to work out both problems to figure out both possible answers on these. That's why we have to split it into two almost separate problems. Okay, now let's look at number 2. So, have x, the absolute value of x minus 1 equals 4. So I have x minus 1 equals 4. Then I have x minus 1 equals, and then you're multiplying this whole side by negative 1. So negative 4. Now I solve them. On this one I add 1 to get rid of it, or move it to the other side. So I get x is 5. Do the same thing over here. Negative 4 plus 1 is negative 3. So our two possible answers are x equals 5 and x equals 3. Okay, now on problem number 3, I'm curious if anyone got it, because I almost didn't. I almost started working it out a while ago. So the absolute value of 3 plus x equals negative 3. If we're taking the absolute value of something, can we get a negative answer? No. So, since this shows that the absolute value of something equals negative 3, that's a lie. That can't happen. So you can't work this one out. It doesn't have an answer. No solution. We can't work that one out because it's saying the absolute value of something equals a negative answer, and we know that that's not true. So if you split it up and worked it out, I'm sorry, you just did a little extra work.
Okay, example 2 says solving an absolute value equation, so we're still just doing the same thing. So now we have the absolute value of 3x plus 9 minus 10 equals negative 4. So the first thing we have to do on this one before we can split it into two equations is move this 10 over since it's outside of this absolute value. So we can also make sure and see, okay, right now this is negative over here, which we can't happen with absolute value, but we don't know if this 10 could change that. So if I add 10 to both sides, negative 4 plus 10 comes out to positive 6. So my equation is now 3x plus 9, or the absolute value of 3x plus 9 equals 6. So now that it's positive over here, we know, okay, this could possibly work. So we take that, and now we split it into our two equations. So I have 3x plus 9, dropping those absolute value lines, equals 6, because we're making a linear equation. And then the other option, 3x plus 9, we're multiplying this whole side of the equal sign by negative 1. 6 times negative 1 is just negative 6. So I have 3x plus 9 equals negative 6. So we solve both of these equations. So over here, if I'm solving for x, I've got to get rid of this 3 and 9. The 9 is just by itself being added or subtracted, so I get rid of it first. So I subtract 9 to both sides. Well, 6 minus 9 is negative 3. So my new equation is 3x equals negative 3. Now I want to get rid of just this 3. I want to split them apart, and they're being multiplied, so we divide both sides by 3, and we get x equals negative 1. So then if I come over to this other side, and I solve it, again we subtract 9. Well, negative 6 minus 9 more is negative 15. So I have 3x equals negative 15. I divide both sides by 3, and I get that x equals negative 5. So my solution here is x equals negative 1 and x equals negative 5. Okay, I want you to, hold on, let me turn this off. There we go. I want you to do problem number 5. I'm not going to make you do all these other ones since these problems take so long. Try problem 5. Remember, you've got to move things that are outside your absolute value to the other side of the equal sign before you can split it into two equations. So you'll pause the video, try number 5, and then when you press play, I'll work it out on the board for you.
Problem number 5 says 4 times the absolute value of 2x plus 7 equals 16. Okay, whenever we rewrite this into two problems, like we just talked about, you can't when you don't have just the absolute value over here. So we're going to get rid of this 4 first. That's being multiplied out front. So since it's being multiplied by everything on this side of the equal sign, I can divide it by that. From both sides of the equal sign, we have to keep our equation balanced. So when I do that, it gets rid of it from that side. I have the absolute value of 2x plus 7 equals, and then 16 divided by 4 is 4. Now I can split it into my two problems. So I have 2x plus 7 equals 4. Then I also have 2x plus 7 equals, and when I multiply this whole side by negative 1, I get negative 4. So now we solve for x. So over here, I have A 2 and a 7 I need to get rid of to solve for x. You get rid of the one that's being added or subtracted by itself first. So I subtract 7 from both sides. 4 minus 7 is negative 3. Then we divide by 2. And I'm just going to keep it negative 3 halves for right now. Okay? It's improper, but we'll leave it like that for now. So then over here, I subtract 7. Negative 4 minus 7 more is negative 11. Divide by 2. And I'm going to keep it negative 11 over 2. If we were to change them to mixed numbers or decimals, this one would be negative 1.5 and this would be negative 5.5. But we're just going to leave them like that. Those are your two answers. Now let's look at example, I believe 4 is next. Yeah.
All right, example 4. Now we're stepping it up a bit. So we're solving equations with two absolute values. So we come up here, example A and B. If you notice example A, we have the absolute value of 3x minus 4 equals the absolute value of x. So we're still going to split it into two problems. We just have to get our variables together first, we just have to get our variables together before we can solve, is what I meant to say. We still get rid of the absolute value first. So right here, if we look at this, everything that's inside this absolute value is going to get multiplied by negative 1 for that second equation. So the first thing we do is we rewrite it just dropping this. So I have 3x minus 4 equals x. Then on the other side, I have 3x minus 4 still because we never mess with this first side. We're only messing with the side that the answer is typically on. Equals, now I would put a negative out front of that. Well, the only thing in there is x, so it becomes negative x now. So you have to get your variables together first now. That's what I was trying to say. I apologize. So we've got to get our x's together. And I have to say I disagree with how they worked this one out. They went ahead and got rid of this x and canceled everything out from over here. And some problems that will mess you up. So I feel like they should have done minus 3x on this one first. Because if they subtract 3x and moved it over, we would have negative 4. 1 minus 3 is negative 2x. But we'll follow theirs. It just, normally we have problems that they tell you this is wrong. So that's why I feel like you should always just do that then. But x minus x, they got 0 because they moved it to this side. 3x minus x is 2x. So they have 2x minus 4 equals 0. Then they added 4 to the other side and got 2x equals 4. And then they divided by 2 to solve for x to get x equals 2. Okay, now on this other side, again, I don't agree with which x they moved, but we'll follow what they did since it's worked out here. So they got rid of this negative x and moved it over with this one. Negative x plus x, 0. 3x plus x is 4x. So we have 4x minus 4 equals 0. So we add 4 to get it to the other side. So we have 4x equals 4. Divide by 4 to solve for x, and you get x equals 1. So our solutions here are x equals 2 and x equals 1. Okay, if you're still with me so far, this next one is probably the trickiest one out of the whole lesson. So if you feel overwhelmed, just take a breath and we'll get through this. It's okay. This is why I want you to write this next example down. I don't typically make you do those, but I want you to write this one down because you see all this work. I want you to have step by step how to solve the hardest one. So that way you have it worked out for you to help you in the future. Okay, so I'll give you a second to write that down. It's the absolute value of 4x minus 10 equals, and then you have 2 times the absolute value of 3x plus 1. So I'll give you a second to write that down. Okay, if you're still writing it, you can pause it, but I'm going to go ahead and go on. So on this problem, first thing we do is write our two problems. So I have 4x minus 10 equals, and then we can kind of just drop those, but they kind of become parentheses since it's 2 times all of that. So we have 2 times 3x plus 1 in parentheses. The second one is the one that makes it kind of tricky because if you remember, I said on this previous problem, we multiplied everything in here times -1. So we have to multiply everything in here times -1. That 2 is not in there, so that 2 doesn't get multiplied by a negative. So they wrote it right here using brackets to show you that it's 2 on the outside times negative times everything in those parentheses. So essentially, it just changes the sign of everything just inside the absolute value. So we have 4x minus 10 on this side equals 2 times, and now we have -3x minus 1. Okay, if that wasn't bad enough, now we have to go back and solve these. This one takes a while. I know these problems take longer to work out because one problem is kind of like doing 2 normal problems. So it takes twice the amount of time. So on this first one, we first have to distribute this 2 and multiply it in there so that way we can get our variables together, our x's together. So when we do that, 2 times 3x is 6x. 2 times +1 is 2. So we have 4x minus 10 equals 6x plus 2. So now we need to get our variables together before our just plain numbers, okay? Because they could cancel out. We don't know. So you always want to get your variables together first. So on this problem, we could move the 4x or the 6x. It doesn't matter because we wouldn't cancel everything out. So they chose to move the 6x. So now, there's been confusion on this. We don't divide because if we were to divide by 6, that would only get rid of the 6 because you would be splitting them apart since they're multiplied. We want to move the 6 and the x together. That's why we look out front and see it's positive, so we subtract the whole thing over. If I divided, I would be leaving the x there and only moving the 6. So we subtract 6x from both sides. 4x minus 6x is -2x. I still have minus 10 equals 6x minus 6x canceled, so we're left with equals +2. So now we're solving for x. So we get rid of this 2 and 10. The 10 is by itself, so we do the opposite and add 10 to both sides. I have -2x equals 12. Now we're wanting to split apart the -2 and the x. So we want the x to stay there. That's why here we divide by -2. We don't add. If I were to add 2x, I would be moving the 2 and the x to the other side. So we divide both sides by -2 and get that x equals -6. Now we come over here to the other problem. So I'm going to start from this row right here where it says 4x minus 10 equals 2 times -3x minus 1. So we have to distribute this 2 in here. 2 times -3x is -6x. 2 times -1 is -2. So my problem is now 4x minus 10 equals -6x minus 2. So we get our variables together. So they added 6x to the other side. So 4x plus 6x is 10x minus 10 equals, and we're left with -2 over here. So we add this 10 over, just like we did on the other side, and I'm left with 10x equals 8. We divide by 10. They went ahead and changed it to a decimal. You could have just simplified that fraction also. Excuse me, you could have divided by 2 and got 4/5, but they got x equals 0.8. So our two solutions here are x equals 6 and x equals 0.8. Okay, I want you to do problem number 8. You don't have to do 9, just 8. So pause the video and try that problem because I know it'll take a little bit. It's okay. Take your time. Don't be in a rush. We're spending 2 days on this video. And then you can press play and I will work it out for you on the board.
Problem number 8, we have absolute value on both sides of the equal sign now. So when we work this one out, again, it's absolute value, so it's going to make 2 problems. So I have on this side x plus 8 equals, and I'm just going to put what I have here, 2x plus 1. Then my second equation, I have x plus 8 equals, you're only ever changing that second side on the positive negative. But what I do is I'm basically taking the whole thing and multiplying it by a negative, or a -1. Okay, so if I do that, it becomes negative 2x minus 1. It basically changes the sign of everything, not just one number, not just your x, that whole side of the equal sign. So now here's my two equations that I have to work out. So right here, x plus 8 equals 2x plus 1. So on this problem, we need to get our variables together first. Always get your x's together before your other numbers in case stuff cancels out. So, sorry, something on my face. Okay, so first let's get our x's together. I can move this one or this one. It doesn't matter. There's not a right or a wrong. So I'm going to move this x. There's nothing out here, which means there's like a little imaginary plus sign. So I subtract it to the other side. I'm left with 8 equals 2x minus 1x is 1x plus 1. Now I subtract that 1, and I get that that x equals 7. Okay, now let's come over here to our other equation. I'm going to get my variables together. So I'm going to go ahead and just subtract the same one. But now I have negative 2x minus 1x. So I have negative 3x, and I'm going to add this one over. So now to solve for x, I've got to get rid of this negative 3. It's negative 3 times x, so I do the opposite and divide by negative 3 on both sides. 9 divided by negative 3 is negative 3. So my two answers on this problem are x equals 7 and x equals negative 3. All right, now let's look at example 5.
Okay, now we're going to look at what's called an extraneous solution. So something we all love to hate about math is that sometimes there's special cases where normally it's this, but sometimes you get this. That's kind of what these are now. We're going to look at some special cases that you can sometimes get. They're called extraneous solutions. So this first example says the absolute value of 2x plus 12 equals 4x. So just like before, we're going to split it into two problems. So I have 2x plus 12 equals 4x, and then 2x plus 12 equals, and we multiply that whole thing by negative, and we get equals negative 4x. So we solve. Here, we're going to get rid of the 12 first. So I subtract 12 from, get our variables together first. I need to follow my own advice. So we subtract 2x from both sides. And we're left with 12 equals 4 minus 2x is 2x. So then we divide by 2 to get x equals 6. Then we come over here and get our x's together first again. So we subtract 2x from both sides. Negative 4x minus 2x more is negative 6x. We divide both sides by negative 6 and get that x equals negative 2. Now, what's the special case about this problem is if we go back up here and look. If you remember at the very beginning, we talked about absolute value cannot equal a negative number, okay? Even though this says 4x, that's positive right now, but it's 4 times whatever x is. So let's look at the two answers we got. If I do 4 times 6, I get positive 24. So it's still a positive answer, so that still works. Then if I plug in negative 2, 4 times negative 2 is negative 8. Absolute value can never equal a negative number. So there's absolutely no way we could get negative 8. So that means negative 2 will not work. So we basically what's called reject it, okay? So we take it and we just throw it out. We reject that answer. We just say no. So our only solution on this one is x equals negative 6 because it's the only one that still holds true to the rule that absolute value always equals a positive number. Okay, before we work out a problem, we're going to go ahead and look at example 6. So this is just another one of those special cases, but on this one we have absolute value on both sides of the equal sign. So we have the absolute value of x plus 5 equals the absolute value of x plus 11. Okay, so when we split it into two equations, we get x plus 5 equals, well down here's the normal one that we do first, equals x plus 11. Then up here, x plus 5 equals, and we multiply that whole absolute value times a negative. So it becomes negative x minus 11. So we work them out. So here we get our variables together. So they went ahead, okay, I'm trying to see how they got to, oh, sorry, we add x to both sides and get x plus x, well, that's 1x plus 1x is 2x, plus 5 equals negative 11. So then they subtracted 5 from both sides. Now we're just solving an equation, and we're left with 2x equals negative 16. So we divide both sides by 2 and get x equals negative 8. So then when we solve the other one, we get our variables together first. Okay, so if I subtract this x, see, they didn't do this, and it's weird to me because later you'll get problems where it would be wrong to do it how they did. But they got rid of the 5 first. I'm going to get rid of the x first. If I subtract x here and subtract it here, x minus x is 0 on both sides, and we are left with 5 equals 11. Okay, they got 0 equals 6 because they got rid of the 5 first. So both cases still hold true for this problem as far as they are a false statement. 0 does not equal 6, and 5 does not equal 11. Y'all aren't dumb. I know y'all know that. That's easy. So when you get to an answer that it's obviously a lie, you know that that is not a solution. So your only solution is the other answer that you got. So on this problem, the only answer, after all that work, is x equals negative 8. So now for problems 5 and 6, or excuse me, example 5 and example 6, I want you to do problems 10 and 12 at the bottom. Okay, you are not going to worry about 11 or 13. Just attempt 10 and 12. And remember, these are probably going to be some special cases, so be aware of that. And then you can press play, and I will work them out for you. This is the last example we're going to look at. So these will be the last 2 problems that you do.
All right, problem number 10. I know there's kind of a glare right there, but it says the absolute value of x plus 6 equals 2x. So just like before, we're splitting this into 2 problems because with absolute value, we can have a positive or a negative version and it still comes out to a positive answer. So, and I already messed up. I'm not supposed to write absolute value when I rewrite it. Sorry about that. I'm going to go ahead and scoop that over. I knew that didn't look right. My bad. There we go. That's better. Now I can solve. So right here, I'm going to get my variables together. Now on this one, there is a right one to move. Because if I move this 2x over, I've gotten rid of everything from this side of the equal sign, which doesn't work. You can't get rid of one whole side of your equation. So we have to move this one. Because when I move it, I still have a number over there. 2x minus 1x is just x. So we're already done with that one. X equals 6. So if I come over here to this other one, again, I have to move this one so I don't cancel everything from one side. Negative 2x minus 1 more is negative 3x. I divide both sides by negative 3, and I get that x equals negative 2. Now, it looks like our solutions on this, let me scoot over a little, are x equals 6 and x equals negative 2. But if you remember, or if you think about it, just like in the example we just did, if I were to go back up here and plug these in to the problem, if I plug 6 in, 6 times 2 is 12. That's positive, that's fine. But when we plug in negative 2, 2 times negative 2 is negative 4. Anytime we take the absolute value of something, there's absolutely no way it could ever equal negative 4 or a negative number at all. So, since that happened, we have to reject this answer. Okay, because there's no way it could ever equal that. So on this one, that just kind of means that negative 1 didn't work. So our only solution on this one is x equals 6. Okay, that's why you'll always hear me say plug it back in to check your answer. That's a good way to double check it because it's easy to forget that. You got a solution, you think you're done. When you plug it back in over here on this side, absolute value can never equal a negative number. Okay. Let's come over here to number 12. So I have 2 plus x equals x minus 8. And then I have 2 plus x equals a negative times x minus 8. So I distribute that, and we get 2 plus x equals negative x plus 8. Okay, first thing we always do is get those variables together. So on this one, it doesn't matter which one we move. I have 2 equals x minus x also cancels, -8. Just look at that. That's very obvious that you cannot have that, okay? 2 can never equal -8. That doesn't happen. So that's a lie. It's false. So there is no solution from that one. So we have to come look at our other one. So now if I get my variables together, -x minus another x is -2x. I subtract this 8. 2 minus 8 is -6. And then I have to divide by -2. And I get x equals +3. Go back and check. It's in absolute value, so it'll work out, but we can plug it in to check. 3 minus 8 is -5, but the absolute value of -5 is 5, so it works out. So again, that one also only had one solution because this was a false statement. Okay? So now I'll give you your assignment, or I'll post in Google Classroom. Not really sure yet, but I'll let you know what you're going to do on this one. But, woo, we're finally done with it, okay? I know that one took 2 days, and it was a long one, because each one is 2 whole separate problems. But we'll get through it. We always do.